Okay, so we got done talking about measurement error, so we're going to look at percentage error, which is going to be similar. So now just dealing with, once again, what is the percentage error. It's going to be found similar. Find the difference from the original to what you got, and then divide that by the actual amount. So here, just a quick reference on how we find the percent of something. So 25% of 15.8. So when it says estimate, so that's about a fourth of 15. So that's pretty close to 16. So you're going to be roughly about 3.9. 3.95 is what I'll say. Okay. Because that's 0.25, so that's, which is a fourth. Okay, so 9% of 38. Well, 9% is really close to a tenth. A tenth would just be 3.8. So it's going to be a little less than that. I'd say this is 3.6. Okay, I'm going to actually change that to 3.5. 3.42. Okay. 1.2%. Well, 1% is just going to be 1.27. And then so the extra 2% is only going to add a little bit more. So 1.2%, I'm just going to say, is going to be about 1.3. Okay, and then 0.53% of 6. Well, 1% of 6 would be 0.6. So 0.53 is about half of that. So this would be about 0.3. And then I'm just going to do 1. And now once again, these are estimates. So I'm just, as I look at it, trying to figure out what it should be. Okay. Last one is 0.06% of 202. So this is going to be a fairly small number. So it's 10% of this would be 20.2. Half of that would be 10.1. 0.06 is close to that, but now we're just going to take the decimal back. So 5% would be 10.1. But now we're going to move that decimal back, or forward 2 to the left. So if you have 10.1, move it 2 to the left. And so you're going to be close to anywhere around and I'm just going to say 1.011. Okay, and once again, these are just estimates, so we're just trying to get close. We can just take the percents, put them into decimal form, and that will give us our actual value. But for estimates, it should be fairly close. And actually, this decimal should be right there. So okay. All right, so plants, bicycles, and crowds. Okay, it says the instructions to care for a plant. It says to water it with 3/4 cups of water every day. The plant has been getting 25% too much water. How much water has the plant been getting? So if it's 25% too much, think of like an increase. So it's getting 25% more. So it's getting 125% of the 0.75. So 3/4 is just 0.75. So if you take 125% of that, so that's going to be 1.25 times 75. and it's tempted to go, oh, well, that's another 25%, or so it's just 25, but but that'd be 25% of 100. So 25% of 75, or 0.75, is going to give us 93, or well, 0.9375 cups. So that's what they've been watering it with, because it's asking how much water has the plant been getting. And so since this was 3/4 cup every day, then I'm just finding how much it's getting each day if it was 25% more, and that would be this 0.9375 cups. Okay, the next one, it says the pressure on a bicycle is 63 psi. This is 5% higher than what the manual says is the correct pressure. What is the correct pressure? So once again, it's 5% higher, so that would be 110%. And so we can set this one up using, 63 over the actual, or what it calls for, is equal to, now it's 105% because it's 5% higher than the original. So then whatever the original was would be the 100%. When you take the cross product, you get 6,300 is equal to 105x. So once again, to undo multiplication of the 105 and x, you have to divide by 105. And so what's going to happen is that's going to cancel out. And then when you get 63,000 divided by 105, it's going to be right at 60. So 60 psi is what the tire should be at. That's what the manual recommends for full capacity. Okay, then the last one here says the crowd at a sporting event is estimated to be 25,000 people. The exact attendance is 2,486 people. What is the percent error? So to find the percent error now, we need to find what the difference is and then divide that by the original. So this was the original amount, or the actual amount. To find the difference, you're just going to take the two numbers and subtract them. Okay, and so when you do that, you get a difference of 14. So 14 people off out of the actual, which was 2,486. Okay, so when you take 14 divided by 2,486, you get 0.0056. So this actually will round to 6. Okay, so the percent error is going to be this times 100. So when you times that by 100, you get 0.6% for error. So percent error is equal to your difference divided by your actual times 100. So that's what we did here. Our difference was 14. Our actual was 2,486. You take the 14 divided by that, and with your answer, you multiply by 100 to convert it to percent, and we get a 6% error. Okay, so right below, I won't spend too much time. Obviously, this is what I was talking about with measurement errors. So they've got something that measures in micrometers. Is an instrument that can measure lengths to the nearest micron. Is a millionth of a meter. So what's it going to be useful to measure? Obviously anything that's really small, less than millimeters. So an eyelash, which is 0.1 millimeter. So you could use it for that. It might not be necessary if it's 0.1 millimeter. Well, actually, yeah, you would want to use it for that. The diameter of a red blood cell, which is typically about 8 microns. So, yep, because this gives us to the nearest micron. And then the last one, it says the diameter of a hydrogen atom, which is about 100 picometers. A picometer is a trillionth of a meter. So that's going to be so small that even this micrometer is not going to be useful. Okay. There we go. It says measuring in the heat. Okay, so it tells us that a metal measuring tape expands when the temperature goes above 50 degrees. For every degree Fahrenheit above 50, its length increases by a 0.00064%. Okay, the temperature is 100 degrees Fahrenheit. How much longer is a 30-foot measuring tape than its correct length? So it increases by a 0.0064% for every degree. So there are 50 degrees above 100. So we're going to multiply that by our 0.00064. Okay, that's going to give us, and this is in percent, we're going to have to multiply it by, or divide it by 100, or move the decimal over 2 to the left when we get ready to multiply the actual value. So when you times that by 5, 50, you're going to get 0.0, I believe it is 32%. So that's what we get. So it's going to be that percent error just from the increase of the 50 degrees. Okay, how much longer is the 30-foot measuring tape than its correct length? So now to do this, we're just going to take its length and times it by the percent error. So you're going to take 30 times, now we have to convert this percent into a decimal, so 30 times. Once you're going to move the decimal to the left, so 0.00032. And when you multiply it together, you get a difference of 0.0096. Okay, so that's fairly small, but there is a slight increase in size or slight error there. Okay, so now to find the percent error, we take the difference here by the actual. So once again, the percent error is equal to difference divided by actual. Our difference is this 0.0096. The actual was 30. So when you take that divided by 30, well, you're just going to get this value right here, because you're just undoing that multiplication. Okay, so that is the percent in decimal form. We're going to multiply that by 100. and then that's going to give us 0.032%. So it's a very small error that you're going to notice with those type of temperatures. Okay, so that's percent error. Once again, you're just looking at the difference that you get from the actual and the measured, or what you know from what the actual is, the difference there, and then divide that difference by the actual, and that'll give you your decimal value of the percent, and then you multiply that by 100 to get your percent error. Okay, so still looking with percents, we're not going to worry about this section leaving a tip. We're going to go to the car dealership. So it says a dealership pays a wholesale price of $12,000 to purchase a vehicle. The car dealership wants to make 32% profit. How much will they make up, or how much will they mark up the price of the vehicle? Well, it's just going to be the original price, 12,000 times 32%, which is which is 0.32 in decimal form. That's going to give us our value that they increased the price of the vehicle by. So when you put that in the calculator, they're going to mark it up an extra $3,840. So after the markup, what is the retail price of the vehicle? So we just add that 3,840 to the original price. And when we do that, you get $15,840. So that's what they're selling the car for. Okay. So now we're going to keep using this as 15,840. And right here, 15,840. Okay, it says during a special sales event, the dealership offers 10% discount off the retail price. So this is the retail price, not the wholesale price. Wholesale is what they pay for it. Retail is what somebody comes in and buys it for. So after the discount, how much will the customer pay for the vehicle? So if it's a decrease of 10%, you're paying 90% of that 15,840. So you can just take 15,840 and you're going to multiply that by the decimal of 90%, which would be 0.9. Or you're taking off a tenth, which is going to be $1,584. And so either way you want to look at it, you're going to get a total cost of $14,256. So that's what you'll pay for it. That's going to be the percentage, or that's going to be 90% of the original cost. So you save $1,500 on the sales price of the car. And if you note, they're still making $2,256 on selling the car. Okay, are you ready for more? It says the car dealership pays the salesperson a bonus for selling the car equal to 6.5% of the sale price. How much commission did the salesperson lose when they decided to offer a 10% discount on the price of the car? So we need to find what 6.5% of 840 is. Okay, and then we also need to find out what the same percentage is of 14,256. And then we can find the difference. So on the first one, so this would be, they make $926.64. So on commission, just for selling it at that sales price. Now, if they would have sold at the original price, they would have made $1,029.60. Okay, so 10% discount. And so the last part, it says how much commission did the salesperson lose when they decided to offer a 10% discount. So we just take the price that the original price at 6.5% minus that 926.64, and they missed out on roughly $100. 029.60 minus 926.64, and the total you get here is $102.96. Sorry, 96 cents. Okay, so that's what they missed out on for commission. So commission is just a percentage of the sale price. Okay, or some might say just a commission on what you make from the profit. But so that would be using commission. There's some jobs that obviously the more you sell, the more they give you a reward for selling more, and that's kind of how they help pay employees that are making more money. I mean, that are selling more items or selling at a higher quantity. Okay, next one. So commission at a gym. So it says for each gym membership sold, the gym keeps $42, and the employee who sold it gets $8. What is the commission the employee earns as percentage of the total cost of the gym membership? Okay, so the total gym membership is $50, right? That's the gym keeps 42, the seller gets 8, so 42 plus 8 is 50. Okay, so to find the percent of commission is going to be what they get, so 8 over the actual. When you take 8 divided by 50, so that would be roughly, oh, that would make sense. You're getting 0.16 or 16% commission. So once again, that's your decimal form. You times that by 100 and you get 16%. So the commission the employee earns is 16%. So now we come down here. It says if an employee sells a family pass for $135, he's going to get 16% of that, assuming the commission stays constant. So we're going to multiply that price by the decimal value of the commission percent. So when we do that, they're going to get an extra $21.60, so $21.60 for selling that family membership. So that's the commission right there. Okay, 16%. Okay, so that's how commission works. It's a percentage, once again, of the selling price, or some might just say a percentage of the profit that you make from a sale. Okay, last one. This is going back to looking at percent error. So from 14.4, or from lesson 14. So it says the jumbo egg. It says to be labeled as a jumbo egg, the egg is supposed to weigh 2.5% or 2.5 ounces. Priya buys a carton of jumbo eggs and measures one of the eggs as a 2.4 ounce. Eggs as 2.4 ounces. What is the percent error? So once again, it's going to be the difference, which is 2.5 minus 2.4. That's going to give us a difference of 0.1, 0.1. So now, percent error once again is equal to difference divided by actual. So this is going to be 0.1, so that was the difference. The actual weight is supposed to be 2.5. So you're going to use 2.5, not 2.4. 2.4, it would make it a little different, but it's going to be fairly close to the same. So 0.1 divided by 2.5, and that's going to give us 0.04. So times that by 100, and you get a 4% error on that 1/8. Okay. Note that even if it's a small amount, you're off, but if it's a smaller number, your percent is going to be higher. All right, so that was looking at percent error, as well as looking at how we use percents in commission, dealing with some of those values there, and also how markup works. So kind of putting percents in another context. We already looked at tips and taxes, but they do get used also for a number of different things. So this kind of gives you that real world application of other places that taxes or that percent